Welcome to Black Hat, everyone. This is Sean Metcalf with Beyond the Mcse Active Directory for the Security Professional.
Good morning, Black Hat. Thank you. As Chris mentioned, this is Beyond the Mcse Active Directory for the Security Professional, and I am Sean Metcalf, the founder of Trimark, a security company, Microsoft Certified Master in Active Directory, one of about 100 in the world, and a Microsoft MVP, a security consultant and researcher, and I own and operate 80security.org. This is my second year speaking at Black Hat. I'm very excited to talk about 80 security here. So what are we going to talk about? We're going to cover some key 80 security components of Active Directory that I think every security professional should know. We're going to then move into the most common 80 security issues that I see when I do Active Directory security assessments for companies. We're going to briefly cover what you get when you raise your domain controller to the more recent version of Windows, give you an overview of Windows 10 2016 security features, and then wrap it up with a Security Pros checklist. So there are differing views of Active Directory. The administrator sees Active Directory differently than the security professional, who sees it differently than the attacker. But none of these have a really good complete picture of what 80 looks like, except maybe the attacker that's been on your network for 8 years. The 80 administrator and engineer, their focus of Active Directory is through their admin consoles. Active Directory users and computers, domains and trust, group policy, sites and services, PowerShell. So they're focused on the operation and reliability and performance of Active Directory. Security professional, I'm sure these look familiar, right? You've got your SIM tool, your vulnerability management console, event viewer. The attacker has a ton of different tools. Look very different than the others, right? They don't necessarily care about event logging except for killing the event logs. They don't really care about the operational reliability of Active Directory other than making sure they can get access to the domain controller. So we have to identify what these different perspectives are and figure out the best way to identify how to protect Active Directory from the attacker and what they're trying to do. So let's talk about Active Directory security. I don't think anyone has Chuck Norris on staff, so we have to do the best we can to protect our environment. Active Directory is created when the first domain controller is promoted, and the default configuration is, well, less than ideal from a security perspective. The standard 80 configuration focuses more on the ease of operation, and not much has changed in the 16 years since Active Directory has been out. This is what most people think of when they think of Active Directory, right? Domain, OUs, groups, accounts. But behind all those OUs and objects, there's a standard-looking database. 80 is a database with tables and rows, much like any other. This information is abstracted and presented in the friendly manner we see in Active Directory users and computers and domains and trusts and all the other admin tools. The Active Directory domain data is stored in this database, in this ntds.dit file, on all the domain controllers in the domain, and they're replicated. The database file stores user, computers, trust passwords, all of which can be extracted if the attacker gets access to this database file, be it on a domain controller or elsewhere on the network. Your Active Directory forest is a complete instance of Active Directory with a single schema, directory configuration, and global catalog. Keep in mind that the forest is the security boundary for Active Directory. The 80 information stays within that forest boundary by default. And all the domains in the forest implicitly trust each other through automatic two-way trust of the parent and the child domain. The first domain in the forest is the forest name and called the forest root domain. So the domain, what is that? The domain boundary is not what you think of when you think of the forest. The domain is just a partition of the forest. It's a domain boundary of authentication, a boundary of domain-level security policies, a domain boundary of replication. And as you can see, the forest is the security boundary because there's a lot of communication among the domains within that forest. I think it's fairly obvious that a domain in a forest is not a security boundary, but we've been treating it that way for years. The domain is effectively an administrative boundary. Does not provide isolation from malicious domain admins. Any domain admin in any of these domains can elevate their rights to be a forest administrator through numerous means. One is to link a group policy to a site that contains domain controllers from multiple domains. Another is to leverage SID history to jump from one domain to another. And if you have trust, you're extending that authentication boundary. Authentication, NTLM and Kerberos version 5 is what's used across that trust. If you create a trust, make sure that you check the box to enable Kerberos AES encryption. Trusts are automatic between domains in an Active Directory forest, but trust can exist between a forest, domains within a forest, or domains in different forests. And it's entirely possible to exploit a trusted domain and jump the trust to leverage access. In fact, Will Harmjoy has covered this quite extensively at harmjoy.net. But let's step away from the Microsoft graphics, because what we're talking about here is how this trust, how domains and forests can be exploited, right? So let's say that an Active Directory forest is like the UFP from Star Trek. And in this analogy, every starship is a domain joined to the UFP forest. And the executive officers on the ship are domain admins for their ship, or domain. And if the ship's executive officer, their domain admin, is compromised, so is the ship, their domain, in the case of the USS Reliant. Since all the Federation starships are part of the forest, they are all implicitly trusted. So when two starships meet, it's not a problem. We don't raise shields because we're all one happy Federation. However, since they're trusted, an officer on one ship can control the critical systems on another, like shields. And as Khan realized, admins in one domain can control another domain in the forest. Don't be like Khan. So when we're talking about Active Directory, we're talking about what's on the left side traditionally, our on-premises Active Directory environment, which has all the goodness that we're used to for 16 years. If you are moving into Office 365 or have already moved into Office 365, you're looking at what's on the right. Azure AD, which was designed for cloud multi-tenant identity. There's no NTLM, no Kerberos, no group policy, just SAML, OAuth, etc. But if you want all the standard AD stuff in Azure, you can get that. There's a preview version. And Microsoft will manage Active Directory in Azure for you. DC as a service. If you're with Amazon, same thing. The simple version is Samba 4, and the premium version is Active Directory as we know it, with some caveats. Although there's no synchronization or federation for Amazon-hosted AD. It's a proxy service. So we're talking about cloud, we're often talking about federation. You have two organizations, a supplier and a purchaser. The supplier has a web app in the cloud, the purchaser has their standard organization, and there's a user that needs to go to that web app to purchase some products. So with federation, what they do is that user authenticates to their local Active Directory as normal, and then they attempt to hit that web app. They get bounced back from that web app back to their federation server on their premises, which then identifies what that web app is, identifies and creates a token, typically SAML, with some attributes that are useful for authenticating and identifying what access that user should have, or at least from its own organization. Then that user bounces back to that web app and provides that token, which is evaluated by that web app to authenticate and determine access. So what does this mean? Traditionally, we've created trust. We've created a lot of trust. What is a trust? Well, a trust is like if I give you my car key or I give you my house key. I trust you. I'm in Vegas. I have no idea what you're doing, but I trust you. Federation's a little bit different. It's more like I have a locker with a key and I put something in there and I give you the key to the locker, but you have no access to anything else. The nice thing about federation is we don't have to open up that trust to other organizations, which we may actually compete with in certain scenarios and partner with on others. The other nice thing about federation is we don't have to manage and maintain all those user accounts because we don't know if that user has moved on to another organization. So in Active Directory, our domain controllers are critical servers. We take a server, we run DC promo, it becomes a domain controller, effectively has a template ntds.file, then it pulls replication from other domain controllers to add the domain-specific information to that file. And then it continues to replicate with the domain controllers in its domain information that updates on itself. But it's the key authentication and directory services component server for Active Directory, for clients and applications. And the security settings of the domain controller define Active Directory security. Hosts and the netlog share and the sysvol share. Sysvol stores group policy information. Netlogon traditionally stores the logon script information. And you need DNS for Active Directory to work, and most of the time you're running DNS services on Active Directory domain controllers. And if it's AD integrated, where you've taken that DNS information and put it into Active Directory so it replicates that way, and you can update it on any domain controller, typically that's AD integrated. AD integrated puts that DNS information into AD and replicates it. So Microsoft looked at this and they said, all right, we have this Active Directory forest with multiple domains. And the domain controllers in each domain only know about their own domain. So how do we enable an application like Exchange to send email from a user in one domain to another? Well, we have the GAL, the global address list. We're used to that. Most organizations have Exchange. The GAL is effectively an abstracted version of the global catalog. It's a replica of all of the objects in the Active Directory forest, but a very small subset of the attributes. So we have all the objects and some of the attributes, which enables very rapid searching of objects in the forest. You can flip a bit on an attribute so that it will be part of the global catalog, but you want to make sure that, as with any attribute, that you understand what the consequences of that are, because they can be quickly and rapidly searched throughout any domain in the forest just by connecting to the global catalog service on the DC. Most domain controllers are global catalog these days. In 2008, Microsoft provided read-only domain controllers, and there was much rejoicing. However, read-only domain controllers are not the panacea. They're not a silver bullet. You can't just deploy them everywhere, unfortunately. Why is that? Well, they're read-only domain controllers. You can't make any changes on them. It has to chain those requests or refer those requests up to a writable. This includes password changes. So read-onlys are not going to store any passwords unless you explicitly say these users can have their passwords on this read-only domain controller. And we can explicitly deny certain users and groups from having their passwords stored on the read-only. If we want a user in a site with a read-only domain controller to authenticate to that read-only, we have to add their account to that allowed read-only password group. Because by default, when that user first authenticates to a read-only, that read-only has no information of the password, so it chains that authentication request up to the writable. The writable handles that authentication and sends it back down. So then the read-only goes, please send me that password so I can handle that authentication myself. Daddy, I want to be able to do that. And the writable will check if it's allowed or disallowed and make a decision off of that. If it's allowed, the password gets replicated down to the read-only. But at that point, that user still can't authenticate to the read-only unless the computer account for that user also has its password stored on the read-only. So a few different caveats. And applications like Exchange hate read-only domain controllers. Why? Because it can't make changes on it. The use cases for read-onlys are typically when you want to put a domain controller in a place that's not physically secure, not a good idea, so use a read-only. Or you have a local admin at a site, not a domain admin, and they need to be delegated access to that read-only, which is fine. There are several read-only attributes. So the first two determine and control which user account passwords and computer account passwords can be replicated to that read-only domain controller. The last two are more interesting because we can identify who's actually authenticated to a read-only domain controller. So that would typically be the user accounts in that site. We can also identify what passwords are stored on that read-only domain controller. So if that read-only is compromised, we can tell those users to change their passwords. And if you have custom delegation, which you should, custom admin groups, which you should, and you have read-only domain controllers, you should add them to this group because it prevents those passwords from being stored on read-only domain controllers. So DSRM, Directory Services Restore Mode, is the default administrator account on domain controllers. It is a RID 500 account. It exists on every domain controller. When the Active Directory admin DC promos up a new domain controller, they type in a password for the DSRM, password 1234, they click next, 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 next. I have a domain controller, ticket closed, I can go on to do other things. The problem is this password rarely changes. Organizations Few organizations actually have a process by which this gets changed automatically. And oftentimes set this registry key, DSRM admin logon behavior, to 2, which means that I don't have to reboot into DSRM mode in order to log in with this account. I don't have to stop the Active Directory service on the domain controller to log in with it. I can log in over RDP. So we have a local admin account on the domain controller. And we know that the password is typically not a great password. And if we set that registry key, it is possible to actually pass the hash using that account. If we can guess what that DSRM account password is, or if we discover knowledge of that password. This is beautiful persistence if I'm an attacker, and I've been on your network and you changed every other password and you forgot about DSRM. Because I can pass the hash, I can connect to the $, I can run DC sync from Mimikatz using this local admin account on the domain controller. So please make sure that you have a process to change your DSRM account passwords. But how do clients find their domain controllers? Well, we have our network devices that have subnets, so we want to take that information and put it in Active Directory with an Active Directory subnet. And we're going to associate that with a site. This is how Active Directory knows where things are in the real world. So when a client starts up for the first time, it's going to query DNS and go, what are the domain controllers in this environment, in this domain? Tell me who they are. And it's going to get a list, and it's going to ultimately pick one of them. And then say, what's my site? And the domain controller is going to look at that client IP address, figure out what subnet it's associated with, figure out what site that's associated with, and then say you're in site Las Vegas. But what happens if that client IP information does not map to a subnet in AD? The client says, DC, what site am I in? DC says, I don't know, don't bother me, talk to someone else. Client tries again, what site am I in, DC, over here? I don't know, try again. This happens several times, and eventually the client goes, you know what, I'm tired of getting brushed off by the domain controllers, I'm going to pick one. And Murphy's Law says that its client is going to pick a domain controller in London when we're in Las Vegas. So what kind of impact does that have? Well, obviously it's a performance impact on the user. And they may connect to DFS shares that are in London as well. But if we're trying to track user activity through our SIM tool, we're typically going to target domain controllers that are local to that user, since we don't want to search the whole thing, because that's going to take a lot of time, especially if we have a large number of domain controllers. But if this user is now connecting to a DC in London, we're not going to see that activity until we expand our search to include all of the domain controllers. But when we talk about Active Directory, we're usually talking about objects and their properties, users, groups, computers. And there's some interesting things that can be in these attributes, like passwords or social security numbers. There are attributes that are protected from regular users on the network viewing them. It's called a confidential attribute. If you need to put social security numbers into your Active Directory, not that I'm recommending that, but if you need to do it, that's the way to do it, because by default only domain admins have access to this. And the extension attributes often have some interesting information, so you want to check that. There's another attribute I want to call out called SID history. So this is for migration scenarios. You have an old domain with an old user account, new domain, new user account. You copy the old user's SID, you put it into the new user's SID history attribute, and when that new user logs on, their token contains all their SIDs, including the SIDs that are contained in SID history. It's effectively cloning the access of the old user. This works for users within the same domain, as well as throughout the forest, and across trusts if SID filtering is not enabled. And you can easily get a report of your users and their attributes by using the Active Directory PowerShell module. I highly recommend this, and I've called out specific attributes that I typically look at. Last logon date, when did they last log on? Password last set, when did they change their password? Admin count, if it's set to 1, they could be a domain admin. We'll cover that in a bit. SID history, custom attributes, service principal name. So if you run this and you find data in the service principal name attribute, this is a service account for Kerberos. Same thing with computers. My favorites are to look at last logon date, which is the last time the computer rebooted, in most cases, Windows specific. The password last set. So by default, Windows computers change their passwords about 30 days. It's a guideline, not a rule. So if you have a computer or computers that haven't updated their passwords in 60 or 90 or 120 days, they're probably offline. But a more interesting scenario is if you have a last logon date, which is 180 days, and the password last set date is within 60 days. That means you have a computer that's active and online, but it's not getting rebooted for patches. We can also identify operating systems, so you can find what operating systems are in your Active Directory, including non-Windows devices such as Linux and Mac, and storage devices like NetApp. Service principal names, the Kerberos enterprise services that are on there, and then any delegation that those computer accounts have. Group policy is very popular in most organizations because it's a click, 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 finish approach to getting standardized user and computer security settings and policies defined. We create a group policy, we configure the settings, and we link it to an OU. So when a computer boots up for the first time, it's going to query Active Directory for its OU location, for its associated computer account and AD. It's going to find the group policies that apply to it through that OU location. And it's going to look in that group policy object for a link to the sysvol location where those settings files are, the group policy template, and copy those down from sysvol. And then the client component of group policy is actually going to apply that. Same thing happens with a user. The user logs on. The computer's looking for that user's OU, identifies the group policies, looks to sysvol, pulls that down, and applies it to the user. So there's an issue there because if we can insert ourselves into that process where the computer is pulling the settings files to actually apply the group policy settings, then we can have the computer apply things that are a little less altruistic. So last year there were 2 vulnerabilities that were patched by Microsoft that were effectively man-in-the-middle for group policy. 014 could reset group policy configuration on a system to nothing. 011, you could actually have group policy clients connect to your machine, your attacker machine's sysvol share instead of the domain controllers. You hopefully have applied all of these, and if you have, I highly recommend that you check to make sure that you have enabled UNC hardening. Because if you have not fully mitigated MS-15011. The other part of this is if I, as an attacker, can modify the group policy object in Active Directory, or if I can modify the group policy template in sysvol, I can also take over your computers because I can change the way that they process and the information that they actually apply. So let's talk about authentication for a minute, because that's kind of key to how Active Directory works. And I love Bane, so. NTLM. Been around forever, right? The bane of our existence as admins. I've had to work that in somehow. You have a user, authenticates, their password is converted to an NTLM password hash. They want to connect to the server. Say, server, I want to connect to the service. The server sends a challenge. The user takes this challenge, encrypts it with its password hash, sends it back to the server. The server goes, I don't know what to do with this. Sends it to the domain controller and says, hey, DC, I've got this user named this. I sent him this challenge. I got this challenge response. What's up? Are they a real user? Is this the right person? The domain controller says, okay, hold on, I'm busy, I'll take care of that. Looks up the user, finds their password hash, takes the challenge from the server, encrypts the challenge with the user's password hash, and compares that value to the challenge response it got from the server. They match. The domain controller says, yep, we're good. Go ahead, that user's fine. There are several problems with the way NTLM works. It's an older protocol. And there's a ton of attacks that have been covered many, many times. If you're not familiar with this, I highly recommend you look them up. Many of them involve man-in-the-middle, because someone can insert themselves between the server and the client and man-in-the-middle that communication and steal credentials. Or they can wait for a client to broadcast and go, yep, that's me, I'm the server, and inject itself into that process that way. And of course, we know pass the hash is an issue because if an attacker can get access to the user's hash, they can impersonate that user until that user changes its password. So Microsoft says applications are generally advised not to use NTLM because it does not use recent strong cryptographic implementations like AES and SHA-256. So we've got Kerberos, right? So the user authenticates to the domain controller, proves identity, says I need a TGT, a ticket granting ticket, an authentication ticket. The domain controller looks up the user's group membership information, looks up their restrictions, writes that into the ticket, encrypts it, signs it, and encrypts it using the Kerb TGT domain Kerberos account. Sends it back to the user. Says, I'm done with you. The user wants to connect to this application server, so it identifies what the service principal name is for the Kerberos service on that server. Then goes to a domain controller, same one or different one. Says, here's my TGT, and here's the service principal name of the server I want to access. I need a TGS, ticket granting service, or service ticket. The domain controller takes that service principal name, looks it up in Active Directory, and identifies what service account is associated with that service principal name. And copies the information from that TGT, effectively, puts it into a new ticket called a TGS, and encrypts it with that service account password hash, sends it back to the user. The user says, okay, great, sends it over to the application server. The application server opens up that ticket, looks at the group membership, says, okay, you're good, come on in. Sometimes that application server will actually validate that that group membership data is correct in that ticket through PAC validation. And sometimes the computer the user is on will actually mutually authenticate that connection to that application server. But there's some issues with Kerberos as well. Originally replay attacks, then pass the ticket, being able to take a ticket and reuse it, overpass a ticket, take an NTLM password hash, use that to get a new Kerberos ticket to impersonate that user, offline password cracking of the TGS, forging tickets, golden, silver, etc. But let's talk about MS-14068 for a minute. This has been out for almost 2 years, the patch for this major vulnerability with Microsoft Kerberos. But I still find organizations that are not patched with this. This is a big deal because the domain controller does not properly validate the PAC checksum, which means a regular user could change their Kerberos ticket to say they're a domain admin. This is much like you go to the airport, you have your boarding pass and you write pilot on it, and you hand it over to the flight attendant, you get escorted to the cockpit. It is that bad. So please make sure that before you run DC Promo or before your admins run DC Promo, that they're making sure that all of the patches are applied on your member servers. So there's a number of weaknesses with NTLM and Kerberos, involving encryption, involving not having mutual authentication. The Kerberos side of things, if it's using RC4 encryption, then it's using the NTLM password hash to encrypt that ticket. And if we can steal the credential information, we can reuse it with either of these pretty much anywhere in the environment, on the network. So Microsoft said, okay, we have a problem. We know we've been using protocols from 30 or 40 years ago, so let's update it to Microsoft Passport. Passport is a two-factor authentication system that combines a PIN with encrypted keys from a user's device to provide two-factor authentication. All right, that's a lot. What does that actually mean? Well, it's still in beta. When 2016 comes out in September, we'll have a much better idea of how this works, but broad strokes are, on a Windows 10 device, we have a TPM chip that generates the user public-private key pair specific to that device for that user. And the public key is added to the user's attribute in Active Directory. The user's device-specific secrets associated with that credential are stored in VSM, the secure world, that lockbox in Windows 10 where even if you compromise Windows 10's kernel, you can't easily get access to it. And the machine data and the user credential information are combined and sent to the domain controller for the user's TGT, that ticket granting ticket or authentication ticket. And since Credential Guard owns the system private key, to get that TGT, if you turn off Credential Guard, this whole process doesn't work. So Microsoft has really thought through this, and again, when this comes out in a few months, we'll get a much better idea what this looks like. But if you want to roll it out in a few months, there are some requirements, which may get updated in September. The key here is you're going to have to deploy some 2016 infrastructure, which makes a lot of sense. And if you have key-based or password-based authentication, you're going to have to deploy some 2016 DCs. So now the fun stuff. The most common AD security issues, as I've seen them in Active Directory security assessments and as I've heard from other people in the security industry. A lot of organizations still have multiple domains in a forest because they thought that was the right way to do things. And to be fair, originally when AD came out, that seemed to be the way to do it. We have realized since then it's not. These older forests have multiple domains for security. We can't really trust this environment, or we have different business divisions that don't really trust or like each other, so we put them in separate domains and the problem's solved. But then if we have trust outside of those extend the boundary and may introduce exploit paths. If you are running under the default settings, which means that you don't have policies that are applied to your domain controllers or workstations or servers, you're running at the lowest common denominator in the world. I recommend you don't do that. Domain controllers need these security policies because your Active Directory security's baseline is based off of your domain controller security posture. And if you haven't configured enhanced auditing or subcategory auditing, you really want to do that at least on your domain controllers, if not on everything, because it goes from 9 categories of auditing to 53 categories of auditing. And you'll get a lot more granular information about what's going on in your environment. You can run this audit poll command to get good information about how auditing is configured on that system. One caveat here, if you think you've enabled subcategory auditing, but you have standard auditing already configured in your environment, and you haven't checked the box in group policy that says override the setting to use subcategory auditing, you're still using the standard auditing and only getting those 9 categories. Unpatched systems. Attackers are not often using 0 days. Not all the time. And we know that if we haven't patched our environment properly, there's privilege escalations that are local or RCEs. These are big deals. We'll patch the RCEs very quickly, right? But we may not work on a local privilege escalation. But we want to make sure we deploy those patches to our endpoints. We want to make sure DCs are patched as rapidly as possible, and preferably with a patching system separate than the rest of our organization. Running old and unsupported operating systems can leave you open to a lot of vulnerabilities. Unless you're paying Microsoft and writing them a huge check every month now, every year, you're not getting patches for 2003, and there's some things that architecturally Microsoft cannot patch in 2003 in Windows XP. So you need to isolate those systems if you cannot get them up to a newer version of the operating system. If your DCs aren't running 2008, you don't have DES Kerberos encryption. I'm sorry, you have DES Kerberos encryption. You don't have AES Kerberos encryption. You can't trust or expect a 10-year-old operating system to protect itself from a 1-year-old exploit. So we mentioned DSRM. We need to make sure that these DSRM passwords get updated regularly and automatically. The simple way to do that is to create a user account in Active Directory and tell all our domain controllers to sync with that account every so often and have that password update on a regular basis. So over-permission accounts, we all have them, right? It's kind of the dirty little secret of every network. We have service accounts of domain admins or with rights that they don't need or more highly privileged than they should be. We've got accounts in admin groups just because. Managers have accounts in domain admins or admin groups. Why? Because if all of my consultants, all of my admins are not here, I need to be able to fix it. Well, that's what a safe is for. Sorry, managers, you should not have domain admin in your environment. User accounts in admin groups. By mistake, by group nesting, or just because it's easier. Computer accounts in admin groups. So if you put a computer account in an admin group, and that computer account gets compromised, then that attacker has the same rights as that admin group. But groups within groups within groups within groups is the reason why we have an issue, or at least part of the reason. So how many domain admins do you have in your environment? You're probably thinking of a number. Hopefully it's less than 50. 200, that's too high. How many domain administrators, that administrators group in the domain? What about enterprise admins? What about accounts with delegated domain admin rights? Are you sure? You really want to know what your admins are, who your admins are, and where they are. Because we have situations like this all the time. We have ADA admins, which is in domain admins, which has critical server admins, and ADA admins, which has server admins? I don't know who put server admins and critical server admins, but yeah, sure, whatever. And then before you know it, Wesley is a domain admin. Or you have someone else that's a domain admin, they don't know they're a domain admin, and they never should have been a domain admin. So what groups have AD admin rights? There's 3, right? Domain admins, enterprise admins, domain administrators. 3, no more than 3. Oh, wait, sorry, 4. 4 groups that have AD admin rights, because there's custom delegation at the domain or the OU level, which gives them rights. Yes, okay, so 4. 5 groups with AD admin rights. The groups that have the ability to log on to your domain controllers are effectively AD admins also. What are they? Well, account operators. If you're using account operators to provide delegation to your help desk admins by adding help desk into account operators, it's not a good way to do it because account operators is way overprivileged. Now these are default rights, so you can actually change this and remove account operators, which would be a good start. But the rest of them, backup operators, print operators, server operators, can log on to your DCs. Remote desktop users can RDP to your DCs, doesn't mean that they can actually get into it. But I don't think these are properly named, so let's rename them. Okay, DC backup operators, DC print operators, DC remote desktop users, and DC server operators. Because these are specific to the domain controllers. But I see a lot of environments that are like, oh look, it's remote desktop users. Let's add domain users to that. That sounds like a good idea. We have credentials in sysvol, files with passwords. We have scripts with passwords. We have group policy preferences with credentials. If you have an XML file in sysvol and you see a cpassword attribute with all that gobbledygook, that's a password. It can be decrypted and the credentials can be stolen. Custom group policy object delegation. If you've delegated group policy object creation to a group or user, and that user creates a great group policy called full auditing. Who doesn't love full auditing? Well, maybe the people that have to manage your Splunk instance, but forget about that. So full auditing sounds great. So a domain admin says, I like this group policy. I'm going to link it to the domain. That way every system gets full auditing. We're good. The problem is they have just potentially compromised their entire Active Directory environment by doing that because they did not remove that user from having modify rights on that group policy. Group policies can do just about anything. I can add local administrator accounts. I can modify the security. I can run scripts. I can deploy malware if I want to. So one of the things you want to check is look at all your group policies. Look at the delegation. Identify who has modify rights. If they're not a domain admin, you really need to scrutinize where that group policy is linked and what it can do. Custom domain and OU delegation. This is a very tough thing to do. I'm not up here to tell you this is an easy thing, but this is the one that will bite most organizations in the butt time and time again. Why? Because let's say you hire a domain admin. He's a nice guy, but just not up to the task. He's been on board for 3 months. He had a project he worked on, he left. He made a mistake. He added something to the OU delegation he shouldn't have. Who caught it? Nobody caught it. Looking at this, it's difficult. This is what it looks like when you're looking at an ACL on an Active Directory object. I'll help you out. He added domain computers to this OU to have full control for this object and all sub-objects. So he basically just said, you know what, all of my domain computers are now OU admins. They have all rights inside this OU. I don't know why. This means that an attacker just needs to compromise one computer in this environment, just one, and get system rights on it. And once they have system rights, they own the computer account in AD and have these rights on this OU, which is full. So Will Harmjoy wrote a great PowerShell module called PowerView, which has a lot of great functionality for red team, but also for blue team members. And one of the functions is called Invoke ACL Scanner, where you can scan your domain looking for custom permissions in your environment. I'm actually going to be working with Will to update PowerView in the next few months so that way we can have some templates for blue team members so you can just run some very easy commands and get a good idea of what you have delegated in your environment. So I mentioned admin count equals 1 earlier. So the admin SD holder object is a system object that hosts permissions, just a template of permissions for highly protected and highly privileged groups and accounts in Active Directory. They look like these. And every 60 minutes, the PDC emulator has a process that runs that enumerates the membership of all these groups, takes all of the objects, stamps them with the permissions from the admin SD holder object and removes security inheritance so they don't get overwritten. It sets admin count to 1. It doesn't go back and clear it out, so this means admin count equals 1 is going to be on these objects. So if you set a custom group or user on admin SD holder, about 60 minutes later, your domain admins group is going to have these permissions on it. And you won't be able to override this. So you want to check your admin SD holder object and scrutinize the membership and custom permissions. So Active Directory security enhancements by operating system. So with 2008 domain controllers, we get Kerberos AES, and we get fine-grained password policy. Fine-grained password policy lets us override the default domain password policy, which means that for our admins and our service accounts, we can have more stringent controls over them. We can say they have to use longer passwords. We can also support legacy users that say they need to support a mainframe environment. So they may need an 8-character password, hopefully not. We have managed service accounts where Active Directory manages the password for those accounts. Authentication mechanism assurance, where Active Directory tracks if a user authenticates using a smart card or a password. And my favorite is the ability to audit NTLM authentication. I highly recommend you enable this. You get a really good understanding of where and what and how NTLM is used in your environment. You can also restrict NTLM, which is the next step. Say no NTLM authentication except for these specific systems. In 2012, we get some constrained delegation enhancements. We get group managed service accounts, where managed service accounts is a one-to-one, one managed service account to one computer. Group managed service accounts, you have group managed service account for multiple computers. AD, again, is managing that password. Compound authentication takes the user credential and the computer credential, combines them for a stronger authentication and determination of where that user is coming from. And dynamic access control can actually leverage that to say only an HR user with department equals HR on an HR computer can access this resource. And PowerShell GUI leverages this also. In 2012 R2, we have LSA protection, which can actually stop a lot of the credential theft techniques from pulling data from LSAS. Now, Mimikatz, you can just install a driver and bypass that protection, but that's a little noisier and it's an additional step. And the PowerShell version may have some problems with that. Protected users is a security group that's created when the PDC emulator is set to or configured with a 2012 R2 version of Windows. With protected users, we add admin accounts to this protected user group. They are not allowed to authenticate using NTLM. They are not allowed to authenticate using Kerberos, RC4, or DES. Their passwords are not cached on that system. They're only allowed to authenticate using Kerberos AES, and their Kerberos ticket lifetime is only 4 hours. Authentication policies and silos, where you can say these users can only authenticate and log on to these systems. Some additional protections around Kerberos delegation. So with Windows 10 in 2016, there's some really nice new features, especially in auditing. The first I call Mimikatz auditing, where we can log and audit what's interacting with LSAS. We have the ability to log and get events when something is interacting with our SAM account database on the local system. Group membership enumeration, and some new fields in the logon events, so that way we have a much better understanding of what's happening. 2016 has a host of new features that are going to be useful to a lot of people. If you're running Hyper-V, you can get shielded virtual machines, which means that the virtual machines and the storage associated with them are encrypted. So the Hyper-V admins themselves can't even access that data. Just-in-time administration limits the time in which an account or group is a member of a group and has that administration access. Just enough administration, GIA, provides controls when you PowerShell remote into a system. You can only run whitelisted commands. So in Active Directory 2016, we have a new optional feature, much like the recycle bin, called Privilege Access Management. Once we enable this, we have the ability to set time to live when we add a new group or account to an existing group. So let's say we have an InfoSecurity vulnerability scanning account that we need to be in domain admins for 3 days. Well, at the end of 3 days, that account is removed automatically. And as we can see, there's a TTL associated with that membership in that group. We also have a new Bastion forest where we have an admin forest support baked into Active Directory 2016. We have shadow security groups where it's kind of like SID history, where the SID from the production forest is used for that shadow security group, which supports that temporal membership, which also supports Kerberos ticket lifetime shortening. So if a group is a member of another group for 4 hours, then your Kerberos ticket's only going to be good for 4 hours. So again, still in beta, but in September, we'll see what this looks like, because it looks very interesting. So to wrap up, there's some interesting AD facts I want to share with you. All authenticated users have read access to pretty much all objects in Active Directory and pretty much all their attributes. And they can view pretty much all the contents in sysvol, even across trusts. And a regular user account could have full admin rights in the environment through the Mcse history, even if it's not a member of any admin group. Or could be able to modify the membership of groups or modify accounts if it's delegated from years ago in a group that's forgotten about. Or potentially that account gets popped and the whole environment gets compromised because that group policy object has improper delegation on it. So your security pro checklist. Who has admin rights to the domain and forest? Who can log on to your DCs? Who is an admin of your virtual environment if you have virtual DCs? Check your permissions in your Active Directory domain, OU, admin SD holder, group policies for permissions that should not be there. Your domain admins need to be protected at the highest level, which means they should only be logging on to trusted admin workstations, admin servers, and domain controllers, and nothing else. Because if a domain admin gets popped, there goes your forest. You also want to limit your service account rights that have highly privileged access, like DA. So in conclusion, regularly audit your Active Directory admin groups and your delegated rights. Because the keys to Active Directory security is isolating admin credentials and isolating your critical resources. If you get Active Directory security right, many of the common attacks are mitigated and far less effective. Thank you very much. I have about 3 minutes for questions, if anyone has questions. Over there, yes.
How often do you see systems or domains that don't have NTLM required services?
Okay, so the question is, how often do I see domains that don't require NTLM services? Rarely to never. But we're trying to get better, right? Security is a journey instead of a destination. We're always trying to improve. And if we can identify by auditing NTLM, we can get a better understanding of how it's being used. Okay, any other questions? Yeah, over there.
What was the name of the PowerShell for?
Power View. Power View by Will Schroeder, a.k.a. Will Harmjoy. Yeah, the slides are actually going to be posted to adsecurity.org in like 5 minutes automatically. So there's a new post that should have them. Let's see, any other questions? I'm looking. Oh, yes, right there. What groups should you put your help desk in? That's a great question. I wouldn't recommend putting it into account operators unless you're a very small environment and you don't have the resources to really do proper delegation. But ultimately, you should have an OU that has your accounts in it. You should do custom delegation and identify what the roles are required. Typically, you have a tiered levels of help desk 1, 2, 3. Help desk 1 will have the ability to reset passwords. Help desk 2 probably more rights. So it's really going to be specific to your environment, but they should be custom tuned to that because your help desk accounts are at risk. Any others? Yes.
We're seeing more and more applications that the vendor insists it has to have domain admin. Do you run into
Great question. Thank you so much. So the prize for the best question is we see vendors that say we need to have domain admins. And I love this question because most of the time vendors are going to say that the account needs domain admins. Why? It's easier to develop, it's easier to test, it's easier to support. Oftentimes a vendor's account only needs domain admin rights when it's installed, and then beyond that it doesn't. Or it needs to be able to reset the passwords on users, or it needs very specific delegated permissions, which can be delegated. So the question back to the vendor is, okay, what are the rights that are required that you're saying it needs domain admins? Because domain admins is not a requirement, it's a solution. So tell me what the requirements are, what are the permissions that are actually required, and we can go from there. A friend of mine had a VPN vendor, said the service account needed to be a domain admin. It turns out it just needed delegated access to change the password for the user if their password had expired. But the vendor didn't want to do that. So And I think I am out of time. So I'll be here for a few minutes, and then we can go to the back if there's further questions. So thank you very much.